Welcome back to the GreenMech TV channel. Step inside one of the UK's most advanced recycling centres, operated by Veolia in London, where innovation, efficiency, and sustainability come together. Every day, dozens of trucks deliver tons of mixed recyclables collected from homes and businesses across the city. Once unloaded onto the tipping floor, the journey of transformation begins. Conveyor belts move the materials through an intelligent sorting system. First, a rotating drum filters out oversized cardboard. Vibrating screens then separate flat items like paper and film from 3D objects such as bottles and cans. Steel cans are pulled away using powerful magnets, while eddy current separators send aluminum in a different direction. Glass is crushed and filtered, and advanced optical scanners use infrared light to detect plastic types, firing precision airbursts to sort them into individual streams. Alongside the machines, trained operators monitor the line and manually remove any contaminants or materials that automation might miss, ensuring maximum purity and quality. Once separated, each material is compressed into large bales: paper, plastic, metal, and more, all neatly stacked and ready for shipment to manufacturers across the UK and Europe. These recycled materials are reborn as new packaging, building supplies, textiles, and countless everyday products, reducing landfill, conserving energy, and closing the loop on waste. Behind every item we recycle is a powerful network of people, machines, and processes working together. This is what a circular economy looks like in motion, and it all starts with the simple act of sorting your waste. Plastics have become an essential part of modern life, from packaging and electronics to automotive parts and medical equipment. But with convenience comes consequence. Without proper recycling systems, plastic waste piles up in landfills, oceans, and ecosystems. That's why advanced sorting technology is key to solving the plastic waste crisis. In this facility, mixed plastic waste arrives from households, industries, and commercial sources. The process begins with mechanical pre-sorting, where oversized objects, contaminants, and non-recyclable items are removed. The remaining materials are spread across conveyor belts and pass through high-speed, near-infrared NIR scanners. These smart sensors detect plastic types by analyzing their molecular signature, distinguishing PE, HDPE, LDPE, polypropylene, polystyrene, and more with precision, even when labels, dirt, or mixed colors are present. Identified plastics are separated using bursts of compressed air, launching each item into its designated chute at lightning speed. The system operates in milliseconds, faster and more accurate than any human could manage. The plastics are then ground into flakes and pass through a second round of sorting. Flake sorting uses color detection, density separation, and additional NIR sensors to remove residual contaminants, ensuring purity down to the particle level. Washing, drying, and delabeling stations further clean the flakes before they're melted and extruded into uniform plastic pellets, the raw material for producing new items. These pellets can be transformed into bottles, containers, outdoor furniture, piping, synthetic fibers, and even automotive parts. Recycling plastic this way saves up to 80% of the energy required to make virgin plastic and reduces carbon dioxide emissions dramatically. It also cuts the demand for fossil fuels like petroleum and natural gas, helping decouple economic growth from resource extraction. But none of this works without precision. A single stream of improperly sorted plastic can contaminate entire batches, lowering quality and recyclability. That's why these systems are driven by machine learning algorithms, real-time data, and constant calibration, ensuring consistent output and minimal waste. Beyond the machines, the success of this system also depends on smart design and cooperation. From consumers correctly separating waste at the source, to manufacturers designing packaging that's easier to recycle. This facility shows what's possible when technology, engineering, and environmental responsibility align. It's not just about cleaning up after ourselves. It's about building an infrastructure where waste becomes a resource and materials loop back into the economy again and again. As global plastic use continues to rise, scaling up systems like this is no longer optional. It's essential, because a truly sustainable future doesn't just reduce plastic waste, it transforms it into something valuable, usable, and part of a better world. Welcome to a modern recycling center, where everyday waste is transformed into new resources through smart engineering and teamwork. After curbside pickup, materials arrive here and are sorted by type: cardboard, paper, plastics, metals, and glass. Conveyor belts move everything through a series of machines, spinning discs, air jets, and magnets, each designed to separate specific materials. Steel cans are pulled out with powerful magnets, while aluminum is repelled by eddy currents. Optical scanners identify different plastics and send them to the right bins using bursts of air. Once sorted, each material is baled, stacked, and shipped to manufacturers who will turn it into new products, like packaging, car parts, or even clothing fibers. Recycling reduces landfill use, conserves natural resources, and helps cut down greenhouse gas emissions. It's a powerful reminder that what we throw away still has value, and that a cleaner future starts with smart choices today.
What used to be discarded as agricultural waste is now being transformed into a valuable and sustainable resource. This is the story of coconut husks, often overlooked yet full of potential, making their way from farms to factories that turn them into biodegradable products. The journey begins with the collection of discarded coconut shells and husks, which in many regions would otherwise be left to decompose or be burned, contributing to greenhouse gas emissions. But in this eco-conscious process, they're diverted from that path and delivered to specialized recycling centers. The fibrous outer layer, known as coir, is separated from the harder inner shell. The coir fibers are then cleaned, sun-dried, and processed into a soft yet durable material. These fibers are used to manufacture a wide range of eco-friendly items: garden planters, erosion control mats, brushes, ropes, mattresses, and even soundproofing materials. Unlike plastic, these coconut-based products naturally decompose and return to the earth without harming the environment. Meanwhile, the hard shells aren't wasted either. They're crushed and turned into activated carbon for water filtration, burned as biofuel, or shaped into decorative goods and homewares. This ensures that every part of the coconut is put to use, supporting the ideals of a zero-waste circular economy. The process is clean and energy efficient, often powered by local labor and simple mechanical systems that don't require large-scale industrial inputs. In many developing regions, this industry not only reduces waste, but also creates jobs and empowers local communities through sustainable enterprise. Moreover, these coconut-based alternatives are finding global markets, replacing plastic in packaging, agriculture, and household goods. Their use helps reduce plastic pollution, conserve resources, and support climate resilience through smarter material choices. By turning waste into something meaningful, this system redefines how we value natural resources. It's a perfect example of sustainability in action, rooted in simplicity, driven by innovation, and powered by the commitment to a cleaner, greener future. Behind every pile of discarded tires lies an opportunity, and this facility is proving just how powerful that opportunity can be. At Lead Reclaim and Rubber Products Limited, waste rubber is no longer a problem but a valuable raw material ready for transformation. The journey starts with the collection of used tires and rubber scrap from a wide range of sources, from cars, trucks, and industrial equipment. These materials are first sorted and prepared for processing, then fed into massive shredders that tear them apart with industrial-grade precision. The resulting fragments are systematically cleaned and separated. Steel wires embedded within the tires are extracted using powerful magnetic systems, while fibers and other contaminants are removed through air separation and filtering. What remains is crumb rubber, a fine, high-quality material that can be repurposed in dozens of sustainable ways. From rubberized asphalt for quieter, more durable roads to soft, impact-resistant playground surfaces and shock-absorbing running tracks, this reclaimed material is giving rise to infrastructure that's not only useful but also eco-conscious. Beyond rubber, the facility also reclaims valuable steel components, which are cleaned and sold back into the metal recycling stream. Every part of the tire is accounted for, reducing waste, conserving resources, and contributing to a closed-loop circular economy. The plant itself is designed for safety and environmental control. Ventilation systems reduce airborne particles, enclosed conveyors minimize contamination, and staff follow strict handling procedures to ensure efficient, responsible processing.
Metal recycling starts with collection, from used appliances, cars, and construction waste, all brought to processing facilities. First, materials are sorted. Magnets separate ferrous metals like steel and iron, while eddy current systems remove aluminum and copper. Next, the metals are shredded into smaller pieces, increasing surface area and making melting more efficient. Each type of metal is then melted in a furnace, purified, and poured into molds to form ingots or sheets. These recycled metals are then used to create new products, from vehicles to electronics, with far less energy and environmental impact than mining raw ore. Metal doesn't lose its quality through recycling, which means it can be reused over and over again, a perfect fit for a circular economy.
Meet the PowerHand VRS, a powerful vehicle dismantling system designed to strip cars with speed, precision, and control. In just seconds, it rips through hoods, crushes frames, and peels away components that would take hours to remove by hand. With its hydraulic claws and rotating grapple, the machine targets high-value parts like radiators, wiring, and catalytic converters, making them accessible for resale or recycling. Every move is calculated, reducing labor, increasing safety, and maximizing material recovery. By the end of the process, what's left is a skeletal shell, ready for shredding or compaction. Machines like the PowerHand VRS are revolutionizing auto recycling, turning end-of-life vehicles into resources, not waste. The PowerHand VRS vehicle recycling system is more than just a dismantler. It's a precision-engineered solution designed to tackle the growing challenge of end-of-life vehicles with speed, safety, and maximum material recovery. At the heart of this machine is a high-powered rotating grapple and a hydraulic shear. Together, they make quick work of even the most stubborn parts of a car. As the vehicle enters the dismantling zone, the operator uses joystick controls to target key components, like engines, transmissions, radiators, catalytic converters, and aluminum frames. With a twist of the claw and a pull of the shear, each part is cleanly separated from the body without unnecessary damage. This approach is far more than brute force. The system is designed for surgical precision. The grapple rotates 360 degrees, allowing operators to access difficult angles with ease. Hydraulic arms deliver consistent pressure, giving the machine the ability to extract high-value components intact, perfect for resale, reuse, or targeted recycling. Traditional vehicle dismantling can take hours and involve multiple workers using hand tools. But with the Power Hand VRS, a single operator can reduce a car to its recyclable components in just minutes. This not only improves safety by keeping workers out of the danger zone, but also dramatically reduces labor costs. Once the valuable components are extracted, the remaining car shell is clean and lightweight, ready to be sent to a shredder or crusher. By pre-stripping materials like copper wiring, plastic tanks, aluminum parts, and catalytic elements, the system ensures that downstream recycling operations are more efficient and less contaminated. What makes this system truly sustainable is how it transforms the economics of recycling. Every car becomes a modular source of raw materials, ferrous and non-ferrous metals, polymers, electronics, all sorted and ready for reuse. This reduces dependence on virgin mining, lowers emissions across the supply chain, and brings us closer to a closed-loop system. The machine itself is designed for heavy-duty operation in tough environments. Its reinforced arms, wear-resistant grapple, and responsive hydraulics ensure long-lasting performance. Many models also feature telematics and diagnostic systems, enabling maintenance teams to monitor performance and prevent downtime. Whether in a scrapyard, a recycling center, or a municipal facility, the Power Hand VRS offers a smarter way to process vehicles. It turns what was once waste into opportunity and transforms old, forgotten machines into the building blocks of a cleaner, more efficient future. As global vehicle numbers continue to grow, so does the need for smarter recycling systems. Machines like the Power Hand VRS don't just make the job faster, they make it cleaner, safer, and more circular. This is industrial progress with purpose. A machine built not only to break, but to recover, to give every car a second life, one part at a time. Construction and demolition sites generate enormous amounts of waste, But instead of sending it straight to landfills, modern processing plants like this one are reclaiming valuable materials and reducing environmental impact. As trucks arrive, they unload a mix of debris, broken bricks, concrete chunks, wood, glass, plastic, and metal. The material is first inspected and pre-sorted by heavy equipment to remove oversized objects and hazardous waste. Concrete and masonry are transferred to crushers, where they're pulverized into reusable aggregate, perfect for roadbeds, foundations, and future building projects. Meanwhile, conveyor systems move the remaining material through several advanced separation stages. Vibrating screens sift out fine particles like sand and dirt. Air blowers separate lightweight materials such as plastic and insulation, while magnetic separators extract iron and steel components for recycling. Wood is cleaned and chipped for use as biomass fuel or composite board production. Plastics may be shredded and sent to recycling centers. Even drywall can be crushed and reused in new manufacturing processes. At the end of the line, what remains is only a small fraction of the original load, dramatically reducing the burden on landfills. This integrated system doesn't just recover raw materials, it reduces emissions, lowers disposal costs, and turns demolition into opportunity. It's a smart, sustainable solution to one of construction's biggest challenges, proving that even rubble can be part of a cleaner, circular future. Bulky furniture waste, like sofas, armchairs, mattresses, and wooden cabinets, has traditionally been a nightmare for waste management systems. It's oversized, filled with mixed materials, and incredibly inefficient to transport or landfill. But the Kumar Ogre Compactor offers a smart, industrial-scale solution that combines power with precision. As each full-sized piece of furniture is loaded into the massive hopper, a rotating steel auger begins its work, slowly, steadily, and relentlessly. This isn't high-speed shredding. It's a high-torque, low-speed grinding process designed to handle dense, tangled, unpredictable waste. The auger pulls the material inward, crushing wooden frames, twisting metal springs, and compressing foam, fabric, and stuffing into compacted output, all in one continuous motion. The system's engineering is built for durability. Unlike traditional hammer mills or shear shredders, the auger has no sharp blades to dull or jam. Instead, its spiral-driven shaft exerts immense pressure, breaking materials down without requiring sorting or pre-treatment. This reduces labor costs, increases uptime, and significantly improves throughput. What makes this especially powerful is the volume reduction. Sofas and chairs are largely made of air. Once compacted, the waste occupies a fraction of its original size. This means fewer truckloads, lower fuel usage, and reduced carbon emissions. Some setups even incorporate smart compaction metrics and automated bin filling systems to optimize hauling schedules and costs. After compaction, the dense output can be pushed into containers for transport or fed into balers for further processing. Any embedded metal can later be extracted with magnets, enabling partial material recovery in the recycling chain. The remaining composite waste can go to energy from waste facilities or be stabilized for responsible disposal. The Kumar system is especially valuable for municipal waste stations, transfer facilities, and large-scale recycling hubs. It empowers cities and contractors to deal with an ever-growing wave of post-consumer bulky waste, particularly in an era where online furniture sales and disposable home goods are on the rise. At its core, this technology reflects a shift toward industrial efficiency with an environmental conscience. It doesn't just destroy, it deconstructs with purpose, making room for smarter waste logistics, greener infrastructure, and cleaner cities. In a world where landfill space is finite and sustainability is urgent, machines like this aren't just helpful, they're essential.